welcome to the latest installment of H2 Tech Talk. Today we are joined by Ron Beck, Senior Director of Solutions Marketing, and Gerardo Muñoz, Solutions Marketing Manager for AspenTech. How are you gentlemen doing today?
Fantastic.
Doing great.
Doing great?
Yeah.
Awesome. Thank you both for joining us. We have some interesting questions for you today. But before we get started, how about you both give us explanation of your roles with AspenTech and maybe a bit
Sure,
of your background.
sure. A little. Thanks, Tyler. I'll start out. My name is Ron Beck. I'm based in Massachusetts for AspenTech. Uh, for the past 40 plus years, I've worked at the intersection of energy, electricity, the environment, and technology. At AspenTech, where I've had a wide range of roles over the past 17 years, I never cease to be amazed at the opportunities that sit in front of us all for further improvement in innovation and in operational excellence. On a personal note, I've explored much of northern Canada by canoe and was formerly a world top 10 touring squash professional. I'm passionate about the hydrogen economy and the opportunities to improve it and to bring it to scale. And that's what one of my main roles is today globally at AspenTech. Gerardo?
Yes, thank you, Ron. Well, yeah, my life's not as exciting as yours, right? But um, chemical engineer by background, been with AspenTech also a bit quite a long time, almost 14 years now, and currently I'm supporting Ron on the hydrogen economy here solutions at AspenTech, but also I'm in charge of CCS solutions, and that's also something I'm very passionate about.
Thank you, Gerardo. You'll have to ask Ron to, invite you on the canoe sometime.
I know, I'm trying to, but
It'll be my pleasure. We'll have a good time.
All right, well, let's get.
Tyler, you'll be invited too. Don't worry.
All right. Hey, I'm game. But anyhow, let's get started with the first question, gentlemen. What is AspenTech's end-to-end pathway to hydrogen?
yeah, I can take that one, Tyler. So AspenTech created these roadmaps or these pathways that we call sustainability solution pathways, right? So on that one, we are it's how we explain how our AspenTech solutions can help across different areas. For example, in the case of hydrogen, we provide guidance on how digital tools can help and accelerate and advance the hydrogen economy. So, for example, we look at these in an end-to-end solutions all the way from production, transportation, storage, conversion into hydrogen carriers, for example, and utilization as well. And then we look at it as well in the context of the entire life cycle, from design, operations, and maintenance, very similar to how the AspenTech solutions apply to other industries. So, for example, throughout the whole value chain, we help with the development of new technologies. Let's say we're helping with the development of the research for hydrogen electrolysis, right? All the different electrolyzers, how we can make them more efficient. And then as we move along in the different value chain, we think about production, how we're making production more efficient, how we consume less energy, how we make the process more efficient, how we prevent degradation. But at the same time, when we're thinking about all these hydrogen projects, we just need to be looking at it at conceptual stage, looking at the entire end-to-end solution, so we can just help to make the best investments, the best decisions for investment, looking at a solution that we have, which is Aspen Fidelis, right? Which is gonna look at that at the entire system to support all these conceptual design and investment decisions. And throughout the whole value chain, our AspenTech solutions look at the simulation, as I was saying, with the our solutions have been plot, has been HYSYS, which are for process modeling. But again, concurrent engineering solutions that are helping to scale and create replicable designs for engineering of these hydrogen projects. But then when we think about operations as well, we think about how we're having our different digital tools that can help to optimize operations, but also integrate with the renewable electricity, right? If we think about green hydrogen. So it's across the entire value chain how the digitalization can provide some value, not only from design, also operations, but making sure that we are reducing the cost and improving the reliability of all the solutions across the value chain with the AspenTech solutions.
So end-to-end digital solutions to support the entire hydrogen value chain. Does that
Exactly.
kind of sum it up? So how does that relate exactly to Born Digital?
So good question, Tyler, as a good follow-up. One of the interesting things about hydrogen is that much you can think of a lot of the activities going on in hydrogen today, of which there are many, as startup activities, even if they're being sponsored by a major player today who's got lots of assets under management. The groups working on hydrogen are very much startup groups. Now, one of the challenges of hydrogen is to improve the economics of hydrogen production, probably by about 300% from where it is today, to make it on par with other energy sources. And most people believe, and we certainly do, that digital tools, AI, and other modeling tools will be absolutely crucial in allowing companies in a very fast time frame to make those levels of improvement. Now, if you could start from the beginning, which is what you're doing with hydrogen, how would you actually design an asset, design a process, design a plant, design a company to operate digitally and to take best advantage of the very rapid changes happening with databases, with AI, with models and things like that? Well, you'd probably design it a different way. You design the data collection systems and you design the models you use in the innovation process to be able to be placed in the final asset and inform the operators and also the engineers as to how the plant's doing and how you can improve it. So that's what we call Born Digital, starting from the very outset of the design concept to thinking about how am I going to enable, if you will, in the future, maybe even an autonomous hydrogen plant, but enable it so that it's informing the organization as to how it's doing. And over the life cycle in hydrogen, where we see that about 80% of the life cycle costs are going to be operating costs, that's really important to optimize the operations. So to have those digital tools which you enabled to optimize that operations. So that's really what it is. And working together with our close partner Emerson, we've one of the sort of leading examples of this is a company in a very closely related green tech field in the plastics recycling area, a company called Clear Cycle in Canada. They've fully embraced this Born Digital concept, and they're just bringing online now their first assets, which are fully instrumented, fully digitalized to help them scale up rapidly into a large company with many assets.
Thank you, Ron. So, I mean, to continue down this, I guess, digital path of a conversation of digitalization, I'm going to bring up AI. I mean, everybody's talking about it. It's a big deal. What's the deal here? Is it helpful? What are your thoughts? Either one
Yeah,
of you.
yeah. So I'll take that again. I mean, I think that um, there's a lot of hype about AI right now, and some people are even saying, well, AI is the key to sustainable business in the future. That might be slightly hyperbole, but it's certainly going to be important. One of the things we think about with AI, and we have about over 100 projects going on across AspenTech right now, and we have 21 different let's say, AI use cases, which are today implemented in our different software systems. Fundamentally, what does AI do for you as an industrial company or industrial enterprise? And really, it falls into one main value proposition, which is it helps you reduce complexity. You have complex assets, complex decision processes, especially when you think about both sustainability and profitability, but also in terms of um, hydrogen, when you think about renewable sources for green hydrogen and then the production, the storage, as Gerardo said, all the way through to the end use. There's a lot of complexity there. So AI has the capability to take huge amounts of data and help the people who are operating that plant and making decisions reduce complexity. And really, the benefits, if you think about it, fall into really three buckets for us. One is agility, letting you analyze lots of data faster so you have agility in making business decisions, guidance, so synthesizing information to provide expert guidance to workers and to managers and executives, and then automation. How do you automate things which are somewhat straightforward but still complicated because the quantity of work that needs to be done to bring it across a workflow. So the automation of all of these processes assisted by AI. One example might be a very simple example. We're working
Mhm.
with a large Chinese company, which is going to be a major player in hydrogen. And they're looking at how do you employ AI at the front end to understand, let's say, what, 12 hours in advance, a day in advance, a week in advance, possibly even a month in advance. What does the weather forecast and weather model tell you? Which most of those weather models today are AI enabled. What do those models tell you about how what the intermittency of the renewable power is going to be, and therefore how can you use that your advanced knowledge to adjust how you're going to operate the downstream parts of your hydrogen production process. So that's really you're automating a lot of things to get that uh, future prediction quickly, so you can make better decisions. So that's maybe a small peek into the ways AI are going to help.
Wow, that's very interesting. How how accurate are these predictions, just out of curiosity?
Well, some areas of AI are performing very well. I think if you look outside of industrial concepts, we've all heard over the past few months of a few major, what I would call misses in terms of using AI, Chat GPT and things like that. And some of the things people have tried to do with it, and it's given some highly publicized mistakes, shall we say. So the way that's a very serious thing in an industry, especially hydrogen, where safety is going to be totally crucial. So there, I think the key is we we talk about how we implement AI. We call it industrial AI, which basically means you're combining the decades of experience in chemistry and physics and electricity, um, and putting those guardrails around the AI. So the software is constantly testing what the AI is suggesting in terms of reality of mass balance of chemicals and of the flow of electrons and things. So yes, it can be very accurate, and we have found a lot of use cases where it's bringing a huge amount of accuracy, but at the same time, it needs those guardrails of what we call hybrid models that allow you to make sure that AI is operating within the reality of the limits of chemistry and physics, which in turn give you the safety envelopes and the performance envelopes you need.
Fair enough. Thank you, Ron. But let's get geared or switch gears a little bit, both to talk about economics a bit. Uh, can you tell us about, and Gerardo, you mentioned it earlier, Fidelis and how it can maximize the economics of business decisions in green hydrogen projects?
Yeah, Tyler. I mean, one of the very interesting things about these green hydrogen projects, right, is that they're very expensive. It's like they're projects that require a lot of money, a lot of investments. And one of the things about these projects is that there are a lot of uncertainties. I mean, there are uncertainties on the technology, but also we are introducing extra uncertainties and extra variabilities when we are connecting with wind and solar with all that renewable energy. So that's a very interesting thing about these projects. So whenever we're looking at the complete system, let's say we're looking at hydrogen production, we're looking at the ammonia processes, the storage, and storage could be like hydrogen storage, ammonia storage, or even electricity storage. You need to be taking into account all these different factors just so you can just be able to make these the best economic decision, right? So what Fidelis is doing, it's actually going to be helping you to do that trade-off between all these different factors that are impacting the entire system. So you can just make the best decision, the best economic decision in terms of how you look into how you define the complete system, right? So what Fidelis is doing, Fidelis is going to be helping you to model at a very high level the whole system. As I was saying, I mean, you can just look at the entire system, or you can just look at a single plant or a single piece of equipment. There are different levels within Fidelis, but the best way to exemplify it and just like to show how it's providing value, it's you look at the entire let's say system from, let's say, the hydrogen production. You include the source of electricity. In this case, we're talking about green hydrogen. So the source of electricity, which be the renewables, could be the connection to the grid, the different storage parts, the compression, the ammonia plant, the shipping, the logistics, everything in there. So it's looking at the entire system, and it's going to be running different scenarios just to make sure that you look at the system and identify what are the bottlenecks that are going to be impacting your production. So in that way, helps you to select the areas or see the areas where you are actually going to be need to focus on. Like, for example, will I need to invest in renewables? Will I actually need to be investing on battery storage? Will I need to be focusing on the storage tank so I can just make sure that I got my hydrogen or my ammonia production there? So will I need to select more electrolyzer, bigger types of electrolyzer, because it's the degradation of the equipment is going to be impacting my entire production. So Fidelity is going to be looking at that. It's going to be looking at the CapEx and OpEx costs and help me to make the most accurate techno-economic decisions so I can know where to put my money. So if you're going to be, if I was going to be summarizing this, the value of Fidelis, it's going to be looking at the entire system, and it's going to help me to make sure that I mitigate all my financial risks on all these very expensive projects, so I can just so I can just move forward to final investment decisions. If that makes sense.
No, that makes a lot of sense. I mean, helping the decision makers make decisions, right? So, okay, well, what pathways does AspenTech have for integrating distributed renewables and storage resources?
Okay, so I'll take that question. Try to move it along quickly here. Sort of a complicated question, but yeah, one of the key opportunities with green hydrogen is, I mean, it's fundamentally grounded in using renewable power. So those today largely are wind and solar, in some cases hydro if you're doing a project in Quebec or Ontario. And those are inherently intermittent, as I was mentioning before. And then those need to be integrated with the hydrogen production. And as Gerardo was mentioning with what Fidelis can help you do is it can help you decide, well, how much battery storage should I put into the system as sort of a buffer to store up power for when the sun's not shining or the wind's not blowing.
Mhm.
So to integrate all of that, you need a fairly sophisticated, what we call energy management system that first of all allows you to contend with this intermittency, but also allows you to make optimum decisions. So it's sort of got two parts. One is manage the coming together of all the renewables with the battery storage and supplying them in an extremely efficient way to the electrolyzers. But the other part is making optimizing the power consumption on a continual basis. So what instantaneous price of that power, whether it's coming from, let's say, all of these renewable arrays, it could be coming through the grid from a remote renewable source. It may have a cost if there's a power company in the middle of that. And then you have the storage. So it can constantly make decisions. If I'm making too much renewable power, now should I turn on the battery storage and fill the batteries? When I don't have the renewables available, do I consume the stored battery power or do I buy it off the grid? It's making those optimization decisions. And in the analysis of several projects which are now ongoing, it looks like the benefit of that, all that management and optimization between the renewables and the generation could be between 10 and 30% of the total power availability and operating cost of the hydrogen process. Now, on the storage side, the big issue there is safety. So you're trying to effectively store hydrogen, you have to either get it to a very low temperature or you put it into a carrier fluid such as ammonia. And in either case, you need to very closely monitor the volatile materials that you're storing.
Right.
So first of all, we have very exact and detailed models, and we've done a lot of R&D on those, working with a few customers to make sure we can understand the exact impact of any sudden change in temperature, for example, of the storage location, or change in pressure of the stored hydrogen. And what is that going to do to the whole system to make sure you have a safe environment all the way through? And the safety here in storage is crucial. And then when you link that back, again, with our partner Emerson, who have developed special detection devices to measure and detect any hydrogen flame that might be created or any leaked hydrogen so that you can instantaneously detect it and then run these optimization models online to figure out what to do about that safety situation. So there again, technology is going to be really crucial both at the front end for integrating the renewables and at the back end to ensure effective and safe storage.
Wow. Well, thank you for that, Ron. Do you have any case studies, examples that you're allowed to share with us?
Yeah, I mean, we have a few customers using our solutions in all these different areas. For example, one of them is our products they have been using our modeling tools, sort of like as a digital twin to model the different fleet of hydrogen plants, blue and like blue hydrogen facilities. And we also got Samsung Engineering that's doing modeling of different areas within hydrogen production, hydrogen liquefaction as well to optimize the processes. As well in the area of ammonia cracking as well, Dusen in our ability, it's modeling the ammonia cracking process to improve the efficiency of converting into hydrogen as well. And within the hydrogen utilization for fuel cells modeling as well, we got an interesting example of Dusen as well that's modeling fuel cells. So all this just in order to optimize and improve the economics of all these different processes.
Yeah, and if I might add, Gerardo, I mean, some of these, Tyler, already have been willing to publicize some of the concrete benefits they're getting. So most of the people working in green hydrogen today aren't willing to share
Yeah.
And that's actually an issue for the industry. We have a lot of people using our technology. To me, if yes, there's a competitive advantage to maybe doing it better than somebody else, but on the other hand, I think if the whole industry is going to scale, more sharing of information needs to happen. But we have, for example, chemical company in Japan that's doing blue ammonia application, and they using the AI approach I mentioned and you asked the question about accuracy of models. Well, by adding this AI capability to the traditional so-called first principles models, they were able to more accurately model the green blue hydrogen process and get a measurable 10% increase in ammonia production by having those models available for operations. So those are the kinds of scale of benefits that even simple applications of modeling is going to get you in the hydrogen arena.
Oh. Yeah, then thanks for expanding on that, Ron. And you made a good point earlier about, companies being a little reluctant to share info, which is a shame because we need it in the industry. Uh, but overall, that was the last question I had for you fellas. Are there any closing thoughts that you wanted to say before we wrap it up?
I mean, no, just thanks very much for hosting us, Tyler. It's always great to be with your team and be on your podcast. We appreciate it. And just uh, a yeah, there's a lot going on in the hydrogen arena, and we look forward to more stories to share in the coming months.
We look
Yeah,
forward
I
to
agree.
hearing
I
them.
gotta echo that. Thank you, Tyler, for having us. Looking forward to see all that excitement that how we advance on the hydrogen economy globally. But also looking forward to that canoe trip.
Right? You
Yeah.
brought it all the way back. Yeah, me too. That's going to be a lot of fun. We can maybe record an episode while we're out there. It might be
Sounds
behind the
good.
scenes kind of deal. But like I said, I thank you. I really do appreciate you both getting on, and I assure the listeners that we will have them both on again at some point in the future. But for now, thank you for joining us for another episode. Please remember to share and subscribe.